Hello guys, welcome to my fourth online tutorial on differentiation. Today we'll look at the chain rule of differentiation. Chain rule will be used in situations where direct differentiation is not possible due to the complexity of the function. By using substitutions, we can make the function simpler and then we can differentiate it using the chain rule. So first of all, we'll look at a function. Right, so this is a question we are having. We have y equals x to the power 4 minus 2x squared, and that entire thing will be raised to the power 5. So this one cannot be differentiated easily using the basic differentiation rules that we know. So what we are going to do here is we are going to use the chain rule and we are going to make it simpler by making some substitutions, and then we will differentiate using the chain rule. Okay, so first of all, if you look at the chain rule, it's like this. uh, as I told you earlier, you can replace this function using some substitutions. So when you use substitutions, this one function will be broken down into several functions. So if I break it down into two functions, then the chain rule of differentiation for two functions will be dy over dx is equal to dy over du multiplied by du over dx. In a little while I'll tell you what is dy over du and what is du over dx. So then if you look at our question, we can write that question. We can, let's say we have this x4 minus 2x squared to the power 5, and we can have a substitution here as u equals x to the power 4 minus 2x squared. That is the inside part here, and this function is raised to the power 5. So now what I'm going to do here is I can substitute this y as u to the power 5, because this entire expression is u and that one to the power 5, and this will be remaining as it is. So now I am going to differentiate both of these functions. First one, that is y equals u to the power 5 with respect to u, and the second one u equals x4 minus 2x squared with respect to x. When I differentiate that, I will get this answer. When I differentiate u to the power 5 with respect to u, I will get 5u to the power 4 using the power rule of differentiation. And when I differentiate the second function with respect to x, I will get 4x3 minus 4x. As 4 is common, I can take it out. So the final expression for this one will be 4 into x3 minus x. Now, by using the chain rule of differentiation, as I showed you earlier, dy over dx is equal to dy over du multiplied by du over dx. So then I can do the substitution. Dy over du is equal to 5u to the power 4. Du over dx is equal to 4x3 minus x. So I will substitute that. So then you can see 5 and 4 will be multiplied together to become 20, and you cannot keep this u term here because that's a substitution. I will replace it back again using the original equation, that is u equals x4 minus 2x squared. So once I do that, the final equation is like this: dy over dx is equal to 20 x3 minus x, that is this part, and x4 minus 2x squared to the power 4, that is u to the power 4. So this is how you can use the chain rule of differentiation to differentiate a complex function by substituting several segments of that function to make it simpler. Thank you for listening, and await more tutorials on differentiation.